Cat, your friendly chemistry tutor.
Single, double, and triple bonds. Covalent bonding occurs when atoms share valence electrons with each other. Some elements have more valence electrons compared to others. The amount of valence electrons that an element has determines how many bonds it could form by sharing those electrons. A single bond has 2 shared electrons. It is relatively long and atoms are loosely bonded, meaning they are not that close to each other. A double bond has 4 shared electrons, and it is a shorter and tighter bond, meaning the atoms are moderately close to each other. A triple bond has 6 shared electrons, and it is the shortest and the tightest bond, meaning the atoms are very close to each other. Based on this trend, the more electrons shared, the tighter and stronger the bond, and the atoms will be quite close to each other. Think of it like this. If Azula shares 1 piece of her food with Leo, and Leo shares 1 piece of his food with Azula, they will certainly bond, but won't be super close, so they will only be distant friends. This represents how a single bond works. On the other hand, if Azula shares 3 pieces of her food with Leo and Leo also shares 3 pieces of his food with Azula, they will have a stronger bond and be super close to each other, just like best friends. This represents how a triple bond works. Let's take carbon dioxide for example. If we draw its Lewis structure, we can see here that carbon has 4 valence electrons in pink and oxygen has 6 valence electrons in blue. The carbon could share 1 valence electron with each oxygen, and each oxygen could share 1 valence electron with carbon. This means that the carbon and each oxygen would have 2 shared electrons in total, forming a single bond. This type of bonding leaves the carbon with 2 lone electrons and each oxygen with 5 lone electrons. If the atoms have the ability to form more bonds by sharing more electrons with each other, they will certainly do it. Because number 1, they want to be closer. Number 2, they want to be better friends. And number 3, they will have more food to share amongst themselves in total. So, if the carbon shares its remaining 2 electrons with each oxygen, and each oxygen shares 1 more electron with carbon, they will now have 4 shared electrons in total, forming double bonds. This type of bonding leaves carbon with 0 lone electrons and each oxygen with 4 lone electrons. Now, do you think that carbon and each oxygen can form triple bonds? No, that is because carbon does not have any valence electrons left to share with oxygen, even though oxygen has a few. Here is your knowledge check. Do the following molecules have single, double, or triple bonds? Please pause the video and return when you are ready. You're back. Let's look at hydrogen chloride. We always start off by drawing the Lewis structure of this molecule. So chlorine has 7 valence electrons and hydrogen has 1 valence electron. They can form a single bond by sharing 1 electron with each other. They cannot form more than a single bond because hydrogen does not have any more electrons left to share. Number 2 is phosphorus mononitride. We always start off once again by drawing the valence electrons around each atom. Nitrogen has 5 valence electrons and phosphorus also has 5 valence electrons. Phosphorus can share 1 valence electron with nitrogen, and nitrogen can also share 1 valence electron with phosphorus right here. That means 2 shared electrons and they form a single bond. Once again, if they have the ability to form more bonds, they will certainly do it. So nitrogen shares one more electron and so does phosphorus. This means 4 shared electrons and a double bond. They still have more electrons to share, so nitrogen will share one more and so will phosphorus. This gives us 6 shared electrons between nitrogen and phosphorus, meaning a triple bond. Although there are a few more lone electrons on each atom, they cannot form more than a triple bond because a triple bond is typically the most stable structure that they can be in together. Lastly, let's look at sulfur dioxide. Once again, we draw the Lewis structure and all the lone valence electrons that each atom has. Oxygen has 6, and so does sulfur. Now, sulfur could share one valence electron with oxygen right here, and oxygen could also share one valence electron with sulfur. Each oxygen and sulfur have 2 shared electrons, meaning a single bond. They have the ability to form more bonds, so oxygen will share another electron and sulfur will also share another electron with oxygen on both sides. This gives oxygen and sulfur 4 shared electrons in total, forming double bonds. Now you may wonder that a triple bond could be formed between sulfur and oxygen. That is correct, but in sulfur dioxide, sulfur and oxygen prefer to stay in a double bonded form as that is the most stable structure for them. Thanks for watching. Please email chemcat786@gmail.com for any chemistry questions, and like and subscribe for more content.